Okay, solving quadratic equations using the very famous quadratic formula. So here's a little tip for those of you who are not very strong in factoring or maybe can't quite get the hang of completing the square. The quadratic formula works every single time to find what the 1 or 2 x values equal. The trick is you have to do all the pieces correctly. Make sure you're not making calculator errors. But if you're not making errors, the quadratic formula will work every single time in every situation to solve a quadratic equation. Now, the cool thing about the quadratic formula is there's this piece of information right under here. That piece is called the discriminant, and I'm going to move this out of the way. Oh, by the way, you use the quadratic formula when it's in standard form. When you have ax squared plus or minus something x plus or minus a constant. When it's in this form, here you have all the pieces. Your a, your b, and your c. Okay, now, although I just realized, yikes. Yeah, that's probably not very good. Luckily, move that out of the way. This stuff right here is what I needed. This information is called the discriminant. And if you simplify, which is what I recommend that you always start off with, if you simplify that piece first, don't take the square root of it, just simplify the stuff under the square root, there's some very cool information. If all of this information under here is equal to 0, then you're going to only have one x value. This is why if this is equal to 0, then plus or minus 0 is just plus or minus 0. You don't do anything with that. You'll just have the opposite of b over 2a, which also is the vertex, by the way. When this stuff right here is less than 0, you're going to have the square root of a negative number, and the square root of a negative number, whatever that number is, you're going to factor out a -1, and the square root of -1 is positive negative I, square root, whatever that remaining number is. That's two imaginary solutions. When you graph something that has two imaginary, it does not, the parabola does not cross the x-axis. So it might be over here, might be over here, or it might be even turned downward. So when this piece right here, the discriminant, is less than 0, two imaginary roots, when the discriminant is greater than 0, there's two possibilities. So I'm going to see if I could, there we go. There's two possibilities. If this is a perfect square, say 100, well then you're going to have two rational roots, because let's say b is 5 and a is 1. Okay, so let's say we have the opposite of 5 plus or minus. Well, the square root of 100 is 10. All of that is over 2 times 1, which is 2. Well, -5 plus 10 is 5 over 2. Well, that's a rational number. Move that, oops. And then -5 subtract 10 would be -15 over 2. Those are two rational numbers. So that's one possibility if d is greater than 0. If it's a perfect square, it will be two rational solutions. If it's an imperfect square, let's say when you do all of this stuff, it's equal to 15. Well then, let's leave this is 5 and this is 1. Then you have the opposite of 5 plus or minus the square root of 15 over 2, and that's what x is equal to. Well, now you've got this irrational number because you can't simplify root 15 any further. So -5 subtract root 15 all over 2, and -5 plus root 15 all over 2. So two irrational solutions. So this is a handy thing, handy piece of information to remember to speed up what you will know that the graph should look like. All right, that's it for quadratic formula. Remember, the quadratic formula will work every single time when solving a quadratic if you're not good at some of the other techniques.